Okay, so in terms of debugging, there are a number of tools you can use which are part of the standard C-type library debugging tools. I'll try to go through how we integrate with those today a little bit, but there are also internal debugging tools in binary C, which I kind of mentioned a little bit previously.
Not sharing your
I will be. I'm just making sure things work for us. I broke it trying to get Bint to look. So, okay, it's working again. Good. And let me share, see if I can get a whole screen shared with you. There's that option. Desktop, desktop 1. How's that? Working? Kind of. There we go. Super. Okay. So there's a number of things you can do in binary C, and I'm going to go through. I'm just going to show you how they're done. They're all in the manual. There's a section on debugging in the manual. You can read that. That's pretty good. I can do better. Thing to load is the binary C debug file, which is this one I have here. And it asks you a series of questions. The first one, do you want debugging output? So let's say yes. So you set that to 1. It's very easy. Then if you scroll down, there's various other options. Probably the one you care about most is the debug expression. What that means is that when this is true, so it evaluates to a number that's not 0, then you send the output statements. And by default, it's true all the time, so it's just set to 1. So I'll leave it like that for now. But you can change it, for example, if I change it here to that, it means it only outputs for the first 10 million years. And then it's
Oh, that's cool.
Okay, so this is useful because you can choose a time range, and in fact, anything you can access in star data you can use. So it's any properties of the stars.
Really cool.
So that's good. There's also this thing here called the debug stop expression, and this is checked every time the debug expression. Sorry, that was good. Every time the debug expression is true, it also checks the debug stop expression, and if that is also true, it stops. So you can put in a failure mode, and it's like assert in C or C++. It's like that. There's also this thing here called the show expression. This thing is prepended to every debug line. So you can then see when things change and that kind of thing. So here is you can see what I was debugging the other day. I was looking at orbital angular momentum and a few other things like that. So that's what's in here. If you want this to be empty, you can just set it to an empty string and it won't put anything. That's fine too. But I'll leave that how it is. That should be fine. And then there's loads of other options in here. You can say whether to put line numbers and file names. I normally leave those because they're useful. Fail on nan means that when it sees a not a number in the text, it fails. It has a very crude detection mechanism. So if you use the word remnant, it will also stop. Okay. So don't spell remnant. I always put a space. I always put rem space nant. That's why you might see that in the code. So,
Remnant?
Ruminant.
That's not what I. That would fail too.
That would fail. Yeah, there you go. You can also fail on an inf if you want. So if there's an infinite number, it can also fail. Normally, that's not really a problem. There's got some other stuff here.
So where is it checking for nans and ifs? Is it in the debug expression?
In the debug string that it prints out. So the whole thing scans the whole thing. The rest of the stuff you can probably just leave. I'm not sure you need to know what any of this does. That should all be fine. So that's okay. So then when you set those, you have to go into your build directory and rebuild. So I'm going to run Ninja to build for me. It'll take a few seconds because again, Zoom's taking all my CPU. I have some coffee. Sounds like gin tonic. It's not. Maybe later. You have to rebuild because all the dprint statements are now being changed all through the code. So normally when debug is 0, you just have an if 0, essentially. Most compilers will strip that completely. They just will never even build it, so they never check. Compilers are smart. But now if I go in here and I run my TBSE script, instead of getting this output, which is the standard test case, we get something like this. All right, so it's loads of stuff. And you can see this bit at the beginning here. This is all the stuff I put in the expression that I showed previously, the orbital angular momentum, stuff like that. The ID number here, every star data has an ID number that you can set. Okay, normally it's -1, which just means it's not using it for anything. And indeed, in the code as it is at the moment, it's not used for anything. But if you are running an n-body code, each of your stars may be given a number. You need to identify them. So it's in a preparation. What's in blue in this column here? This is the time. Okay, so we made it to 10 gig years, which is pretty good. This is the file name, where the dprint statement is, and this is the line number where it is, and this is the output from the dprint. That's just like the normal printf statement in C. There's nothing unusual there, and you can keep running through the code and check all of these. Now, this is often it's a lot of data that gets output, but you can always just, if you're trying to show me where something is wrong, you can just set the expression to only show it between 2 times where you think the bug is located, and just send that. That should be fine, and it should compress pretty well as well. There's a lot of repeat.
These are the things that are between dprints, right?
Dprint.
Yeah.
Dprint for debugging. Yeah, that's right. So most of those things, you will never see through the code. Now, in many places in the code, the dprints are also used like comments.
Yeah.
Because often what's written in these dprints is essentially what would be written in a comment. So you don't have to put both. That makes no sense. So we'll say dprint, I don't know, evolving to this type of star or something, something like that. That's perfectly fine. I have no problem with that. So that's the software way, or say software way to do it internally in binary C. And it's very powerful, and it can work very well, especially when you know something changes and then you want it to stop. And so you can find out exactly where it changes. So that works quite well. There are other options. We often have problems with memory leaks, because in C you have to allocate and free your own memory all the time. You've got to be careful with this. This is never normally a problem except at the end of the code, when you've run a system and you haven't freed all your memory. If you're running a grid and you run 1,000,000 of those and each of them allocates 1 megabyte, you will very quickly be in a bit of trouble. So it doesn't take much to have a memory leak, and that's why memory leaks are absolutely key. Now, in order to test for memory leaks, and I'm going to rebuild without debug, because otherwise it's going to be absolutely tons of output. So you have to give me a second to wait for this. That noise that's just started.
Computer.
Yeah,
Regulation.
waiting to open the door.
Is that what it is? Might be. It came on earlier as well.
Yeah.
Weird. For those of you listening in, there's some kind of weird noise just started in the air conditioning. Maybe it's working. That would be a weird noise.
Yeah.
Come on, Ninja, faster. Need more CPUs. Need the USB. There we go. So it's built. And so now when I run TBSE, I just get the standard out. So there's nothing extra there. You can use some of the standard tools for detecting memory leaks, or indeed bits of memory you're reading that haven't been defined, or buffer overruns, or off the end of an array, this kind of thing. GDB is a very common one, the GNU debugger that runs. You can run TBSE GDB like that, and it sends all the args automatically to GDB. You just type run. There you go, and it runs through it, and it's just run through GDB. And it says it exited normally because there were no bugs, which is good. So TBSE GDB is the way to do that. The other good option is TBSE Valgrind. Anyone used Valgrind before? Very useful tool for finding these things. It's a lot more powerful than GDB. It's a lot slower as well. So if we run it through Valgrind, you see it sits there and chugs for a bit. It's because it takes things like malloc calls and replaces them in software. It also has I think it has a CPU simulator which it runs through. So all your code is going through a simulator. It's not actually going through the CPU directly.
Okay. Emulator.
Yeah. You see, so it's replacing all of these function calls with its own function calls. Then it gets to the end and it says, this is what you want. If things work, you have 0 bytes and 0 blocks are lost, which is good. This is how much memory was allocated in the whole thing, and it did it 7,600 and something times, and it freed it 6,700 times, which is what you want. You want those two to be the same. So there's no memory leak, 0 errors from 0 context. Now, let's put in a deliberate error. Here, this is the main function that I've got up. I'm commenting out free memory, so it should fail horribly. we'll see. I haven't tried this because I didn't practice. So now if we run it through Valgrind, we see what happens. Take a few seconds.
The whole building's going on. Valgrind is doing his job here.
It's like a warp drive turned on.
Yeah.
Helicopter? Oh, there we go. So Valgrind has given me all this crap at the end here. Definitely lost 131 kilobytes. Indirectly lost another 800 kilobytes. Possibly lost 16 something megabytes. So clearly, when you don't free your memory, it will point that out.
Mhm.
So, but that's a good thing. That's what you want. And it tells you where in the code. Now note that it gives you line numbers in the code. That's because Ninja automatically builds with all the debugging options. Okay, so when you build with Ninja, it builds debug by default. Okay,
Is that good?
that sound?
What's happening?
No, I mean the default debug.
I can't change that. That's Ninja's, or Maison, I think it's his default.
But disabling that, wouldn't that make the code fast?
Yes.
Is there a way to
So
disable it?
yeah, you can do that.
Okay,
So
okay, yeah.
if I remove the build directory and do Maison, what is it? Build type equals release, I think it is.
Okay. Yeah.
Like that.
Yeah.
Go, give a few seconds. 4 CPUs. Then if we do here, if I do Ninja minus V, let's go to build directory. Ninja minus V. And if I stop that, if you look through here, you should see, oh, there we go, minus 03. So that's the optimized version.
Yeah, man.
So you have to
The higher the number is.
Yeah, 3 is as high as you need to go. And so be careful. If you want the fastest possible build, you have to specify that you're doing a release, and that's how you do it. There are various options for this in the manual. You can have a look. And but if you do, of course, if you do a build type release, it's useless for doing debugging,
Of course.
because you no longer have your line numbers and stuff stored.
Mhm.
So let's go back to the bog standard build directory. Do Ninja minus V, and you can see here where we've got minus G here, which is that's the one that turns on all the debugging in the code, all the debugging line numbers, and minus 0, which means there's no optimization, because otherwise a debugger will never work. Can leave that going in the background. So that's really all I wanted to say about debugging. I mean, except when you have a bug report, please do not just email me and say it doesn't work, because that's useless. I can't do anything with it doesn't work. If it doesn't build, that's fine, but just at least copy paste me what it says. Send me the log file. Maison has a log, you can send that. If TBSE doesn't work for some reason, send me the output. Send me everything you can send that's useful in some way. And also, the easier thing to do is to have your own branch on the GitLab, and then I can just get your branch and build it myself, and so I can see whether it builds or not. That is by far the best way I can give you support. Makes it much easier. Other than that, let's have a look in. I was going to look in TBSE. See, maybe I should put the free memory back. And I was going to look in TBSE, see if there's any other useful things. I mean, TBSE has a load of other options. You can do things like Valgrind command, like that. If you give it that, then it gives you all the command you need to run Valgrind directly on binary C. That's extremely useful because this has been tweaked and tuned in order that binary C can load, because it needs a certain stack size and stuff like that.
Okay.
And I've also turned on all the leak checks and stuff like that, because I'm as paranoid as possible. There are other tools that it has. Cache grind is another one that's for monitoring cache hits. So you can try to speed up your code if you want. You can also use gprof, which is the GNU profiler. That does work. I mean, I use it sometimes. Cool grind and cache grind are probably the newer versions. They're the Valgrind equivalents. I'd suggest you check the Valgrind page to see what these do, because I'm not really here to support that. And I think that's all you need from this list, at least. The other one was the profile guided optimization. I don't know if many of you have heard of this. So what you can do if you want to have a faster executable, you can run the executable a number of times and it gets profiling information from those runs. And then it uses that profiling information to speed up the code by re-optimizing it in a second build. Right?
Yeah.
So there's a script to do that in the Maison directory. You can run that, it will automatically do everything for you, and it will show you statistics about whether the rebuild is actually faster or not. Often I find it's not, because binary C is already quite well optimized. But maybe on your CPU it's different. It's a very CPU dependent, hardware dependent thing. So feel free to try that, and if it doesn't work, let me know. That's the kind of thing I forget to update. Not many people use it. In theory, you should use it, but in practice, I generally don't. One other thing to note is the concept of a generic build. When you build binary C, normally it's for your CPU that you're building it on. You can also send it the generic option, and it'll show you how to do this in the manual, but you might want to do that if you're building for a cluster, because on a cluster, all the CPUs are different, and so, or maybe different. And so what you want to do then is have a code that will run on all of them, and a generic build will do that. So you might want to do that. That's about it for the technical stuff. I mean, the debugging is not that hard. It's usually just a question of dissecting where the problem is. You find it, and then you fix it. So it shouldn't be too difficult. Any questions? Okay.
I do have one question.
Right.
What's the possible optimization in percentage that this PGO can do?
Last time I tried it, -5%,
Very nice.
which is not very useful. So I don't know. It really depends on the machine. On the older CPUs, it seemed to make a lot more difference. On the newer CPUs, it probably doesn't, but it may make a difference in multi-thread. I don't know. I haven't deeply, but you can try. Some noise coming from someone. Is someone trying to ask a question?
Yeah. I have a question. Abhinaya. Okay. I don't know if it's correct to the context, but while I was getting output for revolving stars, there's a problem. I have two white dwarfs from the types. I can find out they are white dwarfs, but the separation was 0.
Yeah.
Yeah. What does it mean?
It depends how it did it. That shouldn't happen, but you're running quite an old version of binary C there, right?
Yes.
So could you try the same system in a new binary C and see if you still have the problem?
Okay. I'll do that.
And this is something that I should have mentioned, which is that you will often find a problem with an old version of the code. Try it again with the latest version, see if you still have that problem. If you do, then it's a genuine bug. If you don't, then it's a bug that's been fixed. And I'm not going to search for the bug twice, so please make sure you're using the latest version. That sounds like a bug that I vaguely remember fixing, so they should have merged essentially. So then, but I think I fixed that a few versions ago. So if you try it with the latest one, then that should work.
Yeah. Okay, I'll do that. Thanks.
Okay, and if it doesn't, just get back to me and I'll try to fix it.
Yeah, thanks.
And what you can always do, of course, is you can set up your branch to work, but you can also send me the TBSE output. So if you run TBSE echo like that, it spits out all the arguments that it sends. So you can just copy paste that to me. If I have all of these arguments, then I can essentially rerun it.
Okay. Thanks.
Anything else? Many of you guys at the back who've been debugging. It's been debugging, so. No?
I only once did not free memory, and that was the only real time that I had issues.
You only have to do it once, then your machine grinds to a halt.
Yeah, no, you'll notice it very quickly if you really need to change something.
Yeah, I hope so.
Otherwise, usually it just doesn't compile, which is also already very obvious.
So the compiler flags that I've set in there by standard are all warnings, right? So I'm very strict, all warnings. And actually, the new GCC has a lot of extra checks that weren't in the previous ones. It even checks things like format statements for you now to make sure there's no errors in those. I fixed all the ones I found. There's bound to be a few that I haven't quite fixed, but we'll get to those. And so before a release, I always run the script, which checks it with all the other compilers to make sure there's not a single warning. So at least there's that.